Yeah, hi, good evening.
Yeah, hi. Okay, so hmm, okay, let's start with today's discussion. So today we are going to actually start with a discussion regarding star schema. Okay, now this was the doubt asked by a candidate who himself didn't join today, couldn't join today, right? What is the plan today is that we will be dividing this session. I mean, this actually the series, right? We'll be having three parts. We'll talk about 30 to 45 minutes today, and then we'll resume to in the next session. We'll see when is most of you guys available, and then we'll resume that, and then we'll be having three sessions. So first, we are going to talk about few of the important topics, broadly speaking. So let's understand what we are going to talk about today. So to be OLAP versus OLTP, and how is the ETL or ELT comes in picture. So how these two are related. The third thing that we are going to talk about is fact and dimension table. That also we did discuss, but we are going to understand more in depth, and the types of schema. Okay, and after this, there are three types, majorly talking about there are three types, and then we'll be talking about star schema. Okay, so this is the plan for today. Once we understand star schema, then we'll talk about how to redesign our OLTP application. This one, sorry, not application database to this one, OLAP, right? Okay, so this is the plan for today. Let's first understand what is the issue that we face here. So let's check this one. So let's take an example. If your manager needs revenue by product category for last Diwali, broken down by city and age group. In 20 minutes, your query on the 50 million rows production database has been running for 8 minutes. What went wrong here? It means now let's understand. Here we are talking about that we have already have an OLTP database. So if you remember last session we did talk about this, right? So what is OLTP is actually transactional database which is write heavy. We did discuss this in our previous session. So write heavy means we design this database. Let's talk about e-commerce again. So when we talk about this e-commerce database, it means this database is being used to store the real-time data, right? The orders that we are getting in real time, right? So orders will be stored here. So it will be having real-time data, right? So we call it real-time. But then let's think about it. Can we do some analytics on real-time data? So what we do usually, we need some historical data or data from past 2 months, 3 months, or 1 month to actually do some analytics. So as a data engineer, my work is to give a platform to my business team so they can actually do the query there, analytics there, right? So it means that I do not want a database which is write heavy, right? So it means that the tables that has been designed here, the designing, right? Designing of tables and schemas are done in such a way that we can have this real time data, right? And these are normalized also. The second thing is these are normalized tables. So when we talk about normalized means what? Right? So normalized means we do not keep duplicate records or duplicate data here, right? I hope this we already discussed, right? So hence this OLTP database is not serving my purpose. My work now is to provide the database to my business team so that they can run the analytics, or I can help them to write a query for them, right? Okay, just a minute. Okay, yeah. So now let's come back here. So I hope it makes sense, right? That why OLTP is not helping here. OLTP is transactional database, which is keeping the real-time data and which is write heavy. Write heavy means we are getting a lot many write requests. You can say insert queries, a lot many insert queries. And now the tables are designed in such a way that it is actually helping the transaction to be readable, or you can say normalized. It means we do not keep duplicate data here. Now, if you note here, last session, I mean in June, okay, not now. So last session we talked about OLTP and OLAP. So OLTP is transactional database. If you remember the one that we learned in our SQL sessions, right? So those were normalized table. Normalized table, we know that already. It means the three normal forms, right? The first normal form, second normal form, and the third normal form, right? I'll just close this window. Okay, so this was our OLTP, and which is write heavy, right? Write heavy kind of database. So this was the design here. Whereas the one that we are going to work today, or we are going to understand today, is OLAP, which is for analytics. Analytics means it's going to be read heavy. So now let's assume, let's take an example. You have to find a business use case. You have to find some what we say, you have to analyze the data based on the tables which are not joined together, or you can say you have to find some matrices which are not in the same table. Then how are you going to do that? Now let's assume if you have some information in three different tables. Let's take an example here. You have to find customers who bought some, let's say for example, electronics category more, right? So this is your business use case. So here let's understand the OLTP database which we had. It was having one customers table, one orders table, and one products table, right? How do I come to know it's electronics? It means that, let's note here, we had the customers table, then we had orders table, and these two were joined, right? We know that that was primary key and foreign key. And the third one was products. And inside the products, we had the category. Now let's assume to find this information for past 3 months. First, that is one thing, that we won't be having past 3 months data in our OLTP database. We are going to archive that. This is the first thing. The second thing is that we are, if I have to write query for this one, it means I have to write join for three tables, right? So can we say this is a complex query? This is getting complex, right? So it means that my OLTP is not solving my purpose, which I want here. It also means that if I have this database, I need to now remodel, or you can say restructure the tables, okay, to give it to business team. It means to make it OLAP database, right? So OLTP has to be remodeled and restructured to convert it to OLAP database. So here now comes the important topic that most of the candidates are not aware of, right? So they think that we are going to use the same thing when we work on ETL, right? So let's understand, we have OLTP. The first thing that you will be starting with is OLTP. It means some other team is now handling this transactional database. Here, till here, no data engineers come into picture. So this is for development team, right? From here, after that, what happens? Let's note here. From here starts the work of data engineer. You will be provided this one. This is source. We have learned about this, right? The multiple sources. This is one source. We can have some events also, pub sub events, right? If you are aware of some pub sub events or some other marketing platform, it's possible. right? So there are multiple sources, out of which this is one source. The first stage is, what is the first stage? Is data extraction, right? Extraction. So from here, the data engineering work starts. This is the first step. The second step is what? We have staging, right? This is the second step. Third step is we have cleaning or validation, cleaning of data, this data. Okay. So here we have extracted. We are moving into staging. So whatever you want to join, you can join here. And cleaning and validation is almost the same thing. And then we have what? We have transformation. So here you can use Python also, right? Here you can use Python. And after this, you are going to, here comes our important thing, which is here. So you must be wondering, those who are still continuing with the data engineering courses, you must be wondering, where does the data warehouse come into picture? Data warehouse comes here, and now it's going to be our star schema. Star schema is what I'll tell you, okay? But let's understand this one. After this is going to be OLAP platform, or you can say OLTP or database, or it can be any Power BI or whatever it is based on the job you're working right now. Okay, I hope it makes sense. It gives some picture, right? What is happening behind the scenes. So from here, data engineering starts and it ends here, right? But we still have some more thing, right? It's not just this much, right? But this is a huge thing. This is a huge topic, out of which data warehousing comes at this point. That is 3, 4, and 5. Right now, as we just discussed right now, that we have to remodel the tables, right? Remodel the tables how? It means that the tables which were created here, which were normalized, is not going to help us because these were read heavy, and now my database has to be write heavy, right? It means that using minimum number of joins, subqueries, and whatever it is, you have to get your work done. It means what is the important thing here is the performance, right? So business team wants all the analytics very fast, right? It's not going to wait there. So it wants it on daily basis also. It means my performance is very important here, right? Okay. And then it means that if performance is important, no other thing is important, then it means that I can have denormalized tables. Denormalized tables means what? It means that you can have duplicate records, or instead you can say duplicate columns. Okay. So if the data is not normalized, it means denormalized, right? So it's okay to have denormalized tables in OLAP, but here we strictly say please go ahead with normalized tables only. So does it say, it means that before you start with your work as a data engineer, you have to sit together with your team and decide on this part, right? It means you have to decide the modeling of your OLAP database, the tables and the columns that you're going to have based on the original table and columns, right? Okay, so we'll check few examples. It will give you more clarity. Yes. So let's come back here. Okay. So this means the same thing, that we cannot use our transactional database for doing analysis. Why? There is one important thing, that first of all, the transactional database is going to have your real-time data only. It's not giving you archived data or the old data. Right? This is the first thing, right? We do not have any old data. It means you can say past 1 month or till 3 months. It will not be there. And the orders which are, or the data which is older than this will not be in the table itself. It may be in some other cloud storage, right? We talked about this. It can be S3 or something like this. So it means that for analysis, I have to ensure what data I want. Do I want past 1 month data or past 6 months data? Based on that, my sources will differ, right? So it means if you want past 3 months data, you use transactional database. that is the archive tables, right? We talked about this as well, archive tables. Or if you want older than, that is older than 6 months data, then you go for some cloud-based storage, right? You'll be keeping there. That is one thing. Second thing is OLTP schema needs dozens of join for analytics. Why? Because the tables are normalized, right? It means just to get the product category, you need to go to category table, right? So just to get a single value, it means you have to join another table, and so on and so forth. So it is hampering my read performance. Hence, we do not advise going ahead with OLTP, right? Right. Okay. And what is the solution for that? Solution for that is using a star schema. Now, this is a schema inside warehousing. And there are three types of, broadly speaking, there are three types of schemas and which we are going to discuss today. Okay, I hope it's clear. Okay, so simple thing, let's understand the difference, because if you do not know this one, you will not understand the star schema. So it's a simple thing, though we have discussed this previously as well, but let's understand this one, that this is process transaction fast and this is for analytics. This is real time, this is for analysis purpose. This here we need historical data, right? And this is for short insert, update, delete, and this is for complex select. Here we still have insert, but insert is when we are loading the data, right? Okay, usually we don't have update and all these things, but right, we will be having select for all kinds of analysis. Here we have normalized design. Here we prefer denormalized, right? Write performance is here important. Here read performance is important, right? And here, this is the example of the database, order management, CRM, ERP. Here we talk about data warehousing. It means the old data which is designed in a such a way that you can write complex select statements. I hope it makes sense, right? Okay. Yeah. Okay, now let's come back here. So why not just report from production? Now let's be honest here that already production database is being accessed by multiple users, millions of users. So we can't use the same database for analysis, right? And again, we want historical data. Hence, this doesn't serve our purpose, right? Okay. Okay, so this was the one I was talking about. From OLTP, you go to extraction, staging, cleaning, transform, data warehousing, and OLAP. It means your ETL, whatever you call ETL or ELT, is going to be here. So this is the ETL or ELT, right? Whatever you are going to work with, whether transformation first or loading first, it depends on. So this is the pipeline. So the pipeline that we call is this one. This is whole is pipeline. Okay, but again, this is not just limited to this one. We have some more responsibilities as a data engineer, right? Okay, so step 2 to step 5, 1, 2, 3, 4, 5 is going to be this one, right? Okay, so here now let's understand. This is very important slide. Please focus here. So here OLTP tables are the one that we created, right? If you remember our SQL sessions, this okay, we did yeah, okay. These 5 tables we did create, not these 3, right? And here we will be having a staging layer also. We have done this as well. So where the same tables we created with STG as the name, right? So this we did already. We have the staging table where we put the clean data. Okay. After that, then we will be working on data warehouse. It means OLAP database. When we are working on this database, that time we are going to rename. Just give me 1 minute, okay? Okay. Now let's come back here. Yeah. So we were actually talking about this one. Huh? Yeah. So here it means that we are going to now design the tables based on like this, right? Okay. So here it means we are going to have the fact tables and the dimension tables, right? So we will talk about fact and dimension table. That this is very important irrespective of the schema that we are going to use here. Now this schema is not the schema that we talked about when we created the tables. Okay, this is just the design or the design pattern, right? So if those who come from development background, right, developer background, they know that what design patterns are. So it's actually the design pattern and not the schema when we talk about. So if you remember, we created order management, right? Order management, and we created one payment management as the schemas, right? These were the schemas then we create. Is not the schema that we are going to talk about. This is a different schema and this is the different schema, right? The word is same, but we give different names to that. So here, this is what we are talking about. So OLAP is read heavy. OLTP has many small tables needing, it doesn't stop joins, right? Star schema flattens dimensions, right? It means the same analytics now can be done using one or two joins instead of multiple joins if we use this one, right? Fact table and dimension table is more important that we need to understand today, right? Okay. So now let's come back here. So usually what we do when we talk about OLAP tables, we are going to now name the tables starting with fact or dimension. So what is fact, what is dimension? We'll talk about that. Okay. Hmm. Okay. Now let's come back to what is fact and what is dimension, which is very important. Okay. Yeah. So fact table means that, okay. So here fact is one table, is a type of table. Okay. And we have dimension type of table, right? So there are two types of table. Broadly, first we need to understand which are going to be the fact and which are going to be the dimension table. So when we talk about fact table, we say those tables which are giving me measurable business events. Okay, we call them fact table. I'll talk about that. And dimension tables are the one that stores descriptive information about business. Okay, now let's compare it with the ones that we had in our database, right? So it means that what tables are called fact table means here we can say orders table. Now orders table is giving me some measurable business events. It means that from here can we say how many orders were being placed, right? Or let's say payments. It is giving me a fact here. Fact is what? That the payment has been made and what was the amount for how much amount the payment was made, what was the transaction ID, and what was the payment method that was used. Right now, these are giving me some measurable business events, whereas these are what? These are actually the one here. Majorly, we talked about numerical data which is giving me some information, some matrices. Okay, here we talk about descriptive data. Descriptive data means what? That here we are going to talk about, let's say here we have okay, so we have order items. Okay, order items also we can put in the measurement because it's going to give me how many quantity was placed and what was the amount, right? But here let's understand, here we can say all the data related to description. Let's take an example, customers table. Now customers table, customer name is giving me information about the customer, right? It is giving me information about a column. Similarly, we talk about products table. Product, and here we have product name, right? So product name now is telling me the description about the product, right? So similarly, we can have category also, category name, right? So now this category alone is not giving me any information. no one is going to ask like how many categories you have. That is already visible from the application, right? No one is going to ask you how many products are there, right? No one is going to ask you how many customers have registered, but they will instead ask you how many active customers are there and how many inactive customers are there, right? That makes sense. Okay. Okay, so here we can have fun, some more examples, but let's talk about these three only. From here, can we say how many orders were placed of this much amount? Let's say above 30,000, right? How many payments were successful and failed, right? And then you can say that how many orders, generally how many items are being placed in each order. Let's say every customer is placing order for 3 items at least, right? So we can say minimum 3 items is being purchased in each and every order, right? Now this is giving me some measurable business events which I can give to the business team, right? This is more meaningful. This is not that important, right? Now business team is not going to ask you what is the name of the product, right? Now business team is not going to ask you the name of the category. Okay, so this is some description, but majorly we have information which is measurable, we put as a factable. So it means that now the naming is going to be like this: fact underscore orders, fact underscore payments, right? Fact underscore order items. Okay, and then we can have fact underscore inventory is also possible. Now this tells me the inventory, how frequently we need to replenish because my inventory is getting stocked out, right? So this gives some measurable matrices to the business team. So now these are actually fact tables. Dimension table is going to be dimension underscore customer, dimension underscore products, dimension underscore category, and so on and so forth, right? I hope this gives some idea, but once you start using this, you will get more clarity, right? So let's come back here. Okay, so here is the difference between fact and dimension table. This stores some business event. This stores the descriptive detail, which is not that important sometimes maybe, but we can still get it using the dimension table. Mostly numeric and keys. It means that here we are going to have important keys like order ID, right? Product ID, and then customer ID. So from here, can we do some joining? Okay, the first thing is we won't be needing the join, right? Because we are going to design this such that we do not need join. Or if we need, we'll have 1 or 2 join maximum, and that is going to give us all the information needed by the business team, right? So these are sales, orders, payments, and this is customer, product, date, and store, right? Usually very large. So this is usually very large. I mean, the rows are too much. Here we have smaller information. So let's be honest here. Categories can be minimum, right? Categories can be 10 to 15 or 20, right? We cannot expect more than that, right? Similarly, but the orders can be in thousands, 10,000s, and so on, right? Okay, right. And then customers can be huge, but again depends on some situation. You will see customer is a fact table. Some places you will see customer is a dimension table based on which application you are working with. Okay, so this is usually decided in the team meeting. So what has to be dimension, what has to be your dimension table and the fact table, you need to present as a data engineer, and then it will be discussed among the team members, right? Keys and measures will be the one that is important here. Aggregation now here can be used. Why we can use aggregate functions like sum and average and count? We can use here. Why? Because we have mostly numeric values here, right? Now here you can't use sum on product name, right? This doesn't make any sense, but here we can, right? So important tables are going to be fact table. The supporting tables are going to be dimension table, right? I hope it makes sense, right? Okay. Here we can do grouping. So if you want to group based on category, you join this with the fact table. Okay. I hope it makes sense. So example columns are quantity, amount, and discount. Here we have name, city, category, brand. So if you want to group based on city is also okay, based on country is also okay, and based on brand and category is also okay. So grouping and filtering is okay from here, but aggregations and calculations will be this table, right? Okay. So far, I think it's okay, right? Now, how to decide which table will be dimension table and which will be fact table, right? How do we decide? We understood the concept that there is fact table, there is dimension table. We understood the difference also. But now, like how to decide? What are the factors on the basis of which we have to decide that this is the fact and this is dimension table, right? So let's understand this one. So we have some important things that we should be aware of before deciding, right? So let's talk about that one by one. Okay, so the first thing on the basis of which, so why we are discussing fact and dimension is, let's understand here all the three schemas that we are going to talk about. That is the star schema, and then we have snowflake schema. So snowflake is not the cloud provider, okay, it's a schema name. And then we have galaxy. So this is just the design pattern which uses fact and dimension table. So if you do not know fact and dimension, we cannot go ahead with schemas also, right? So this is important in order to understand. Everything is going to be the same. Star will also have fact and dimension here also, but the how they are being connected together will be different, right? It's a simple difference, but we should be aware of fact and dimension before jumping into the schemas, right? So let's understand this one here. Okay, so the first thing that we need to be aware of, that how to decide which is fact and dimension, right? This is our doubt. So the first thing is, let's talk about this one. First, we need to decide, does the table store actually business event? This we already understood. So it means that order items. Okay, then we can have inventory, sales, and payment. These tables are going to be fact table. Okay, this is one thing. Next, come back to second thing. So the second point is going to be, does table contain measurable numbers? So the same thing we talked about, it means what columns it's expecting here. Amount, quantity, okay. Then we have discount. Then we can have tax, okay. Apart from this, we can have profit, some rating or whatever it is. We can have many numeric values. So if you have numeric measurable values, then these are again the fact table. Okay, then the third thing is, okay, so here, does the table describe an entity or object? It means that description of an entity. What entity? It can be, again, the same thing, customer, product, okay. Then we have store, employee, and all those are actually dimension table, okay. And it also means that how to name these tables. You need to name them like this, okay. You have to name them like this. This is the preferred way, but you may come across scenarios where the companies don't name the tables like this. That is also possible, right? That also is, it again depends on company to company, right? Okay, then the next thing is, same thing, will the user be able to filter or group? So if you want to group and filter, those tables will be actually dimension table. It means if there are columns which are used for grouping, then it's going to be dim table. This we know this already, right? And The fifth thing is, if you want to use aggregate functions, right, on columns, if you want to do like this, then it's going to be a fact table. Okay, so these are the 5 things on the basis of which you need to decide that which one is going to be fact table and which one is going to be dimension table. Now let's understand all the 3 schemas. We'll try to understand. Okay, so the first thing that we need to be aware of, that there are 3 major types of schemas. Major type, okay, apart from this, there are 2 more. But the most common is star schema. Okay. Star schema says that you are going to have one fact table and multiple dimension table. Okay. So here, when we talk about one and multiple, okay, this is multiple, right? So we can say n here. It means that if you remember, we worked on order management, right? When we worked on order management, we had multiple tables, right? Multiple tables. And from that, we were using orders table, okay, orders table and customers and so many, right? We had, I think, 3 to 4. So here it means that if you want to change this table, you can have one fact table. So let's take fact at orders, right? And then you can have 4 or 5 multiple. Okay, you can have multiple dimension table joined with this. How it is joined? Using foreign key, primary key, right? So here you can have customers. This we just talked about. Here you can have dim underscore products. And here you can have dim underscore stores, right? Okay, so here why it is star schema? Because you can see star like structure here, whereas there is one fact in the middle and all the other tables are connected to this fact table. It means that, can we say, using a single join, we can join this also, we can join this table also, this table and this table, right? It means that here we do not have some more dim table where you have to keep on joining, right? So it's not like it's a chain, like one is connected to other and another, not like that, right? I hope it makes sense. So if you want to have some information to get from any of this dim table, it means you can directly use just 1 or 2 joins, one join for this one for this one for this one for this one, right? This is the maximum you can go. But you won't be needing everything in the same business logic, right? Same business use case, you won't be needing that, right? That's the fact. Okay, so I hope it makes sense. But here, let's talk about this. Here we are talking about e-commerce and not just order management. Not just order management, we are talking about e-commerce, right? So here it means that we may have multiple schema. Now again depends on how you are going to design it. Here what I did, I exactly copied from the previous schema. We had orders, customers, products, and if let's say we have store also, I just exactly changed the name of the tables to fact and dimension. But this is not going to be the case here, right? In practical scenarios, data engineer has to remodel the input data. Okay, so whatever the input data you are getting, now you have to redesign and remodel and create some new tables. It may happen that, if you remember, we had payment management. Okay, we had payment management schema also, where we had the payments table, right? So it means that now this table may have some information from the tables, and you can give some different name. Completely you can give a different name. Let's take an example like this, right? So it means that now you are combining multiple schemas together and creating a single fact table. That is the reason, if you remember the slide that I showed you, it had like lot of records, right? Multiple records, many records, right? The data is huge here, right? So let's be honest here, you won't be actually completely renaming the tables. exactly the same thing? No, it's not going to be the case. You have to remodel. So that is the reason we say we have to remodel the tables. And this is a good work which data engineer has to do, right? If you are lucky enough that you are joining a table, you are joining a company which has already completed this stage of data engineering, then you don't have to do that, right? Okay. So in that case, you just have to maintain and monitor the pipeline. Okay, I hope it makes sense. This gives some sense, right? Okay. Now, similarly, we have two more, which is called Snowflake. Snowflake is exactly same thing. Snowflake schema is almost the same thing, but here there is a difference here. Difference is that is exactly similar to star schema with further normalization. So it's like star schema plus normalization. Normalization means what? We have more dim tables. So let's take an example. I'll talk about this one. We have fact sales. Then we have dim here customer. Then we have dim here date, right? Here we have dim product. Okay. And here we can have some more which is joined here, which is dim underscore category, and from here we can have dim underscore brand also. So if you see here, this is further normalized. This is normalized form. It means that I tried to remove the duplicate data from this and put it here. So now this is normalized. So Snowflake schema says that it is similar to star schema, but with some normalization, right? Okay. Now next thing is Galaxy. So Galaxy will be comprising of multiple stars, right? Can you relate to it? Is the fact, right? We say Galaxy is having multiple stars. It's exactly same thing. It's going to have multiple star schema. But these star schema will be related then. How it is related? I'll just show you one last thing here. So these are connected together. Okay. So how it is connected? Let's take an example here. So we have dim underscore date. Then we have dim underscore product. And then we have fact underscore, let's say returns. Returns means the order which are returned. And then dim underscore store. Anything. Okay. Here you can see we have a fact table. And here we'll come back to this. We can have fact sales, the one that we had already previously. And here we have dim underscore customer. It means that multiple fact tables are connected together, right? Now, what is the advantage of this? That you can have you can handle broader business use cases, right? So business metrics that they need, you can join multiple facts table together, and now you can give them more information in the same metrics, right? In the same query, right? So here, what is the advantage of using this? That you can have multiple business processes and useful for enterprise level data warehousing, right? Okay, so here you see we have one common, this is a common dimension table. So using this, can we reach here, right? That's possible. So that is the reason. So broadly speaking, we go ahead with star schema or Galaxy, either this or this. Okay, so that is the two commonly used data warehousing schema that you see once you start working. So I think we are done for today. So the next session, we are going to talk about how to redesign the existing tables. So the one that we have already, right? Here we will be starting with how to now actually divide the existing OLTP database into OLAP database. Okay, so here we'll be able to see how we are actually categorizing the columns from the one that we got previously. So I'll show you the database which is in OLTP also, and how we are modifying that or remodeling that into OLAP database also. So that is the one that we have planned for next session. Okay. And I'll be providing you the create statements as well that you can run. Okay. I hope it's okay, right?